part 2 of lesson 3.1, graphing equations of the form y equals mx plus b. We want to graph the equation, in this case, y is equal to 5x minus 3. So what we might want to do here is work with a table that I have noted over here on the right-hand side. And so what I'm going to do is I'm just going to pick some numbers, and I kind of like to have a good mix in there, so of positive and negative numbers. And I'm going to kind of keep them pretty close. So what I'm going to go ahead and do now is I'm going to evaluate, just like we had been doing in the previous video. So just as an example, if I'm going to work with the negative 2 first, I'm going to have y is equal to 5 times negative 2. So I'm substituting negative 2 in for the variable x minus 3. Again, my order of operations says that I should do the multiplication first. So I'm going to get negative 10 minus 3, and then a negative 10 minus 3 becomes a negative 13. So here is my answer. So in other words, I have an ordered pair of negative 2, negative 13. And now I can come over to my graph that I have on the left, and I can locate negative 2, and then locate negative 13. So that would be all the way down here. I'm going to make that point nice and big so we can see it. What I would like you to do is go ahead and pause the video and continue to fill in the table. Once you're done, graph everything and then play the video to make sure that your result looks very similar to mine. Here are the results from our table of values. So I was able to create all of these coordinate points. And what I want you to notice is that we are creating a line here. So if I were to maybe use a lighter color here, if I connected my dots, notice that my line is actually going through all of the points that I've graphed so far. And what I want you to understand is that we are actually displaying a full solution set for our equation here. This entire pink line that I've drawn, it's actually made up of a bunch of little points that we would get if we had picked a bunch of different numbers for x and then calculated what the y value should be. So it's not necessarily a solid line per se, or just for the sake of drawing a line. It's actually a full collection of all the points that make up the solution set for your equation. This is why we also want to use arrowheads at the opposite ends of the line that we've drawn to indicate that it's going to continue to go off of the page. So we actually have more solutions than what we can actually see on our graph. The other thing that I want you to note here, this point is actually kind of special. This is known as the y-intercept. The y-intercept is the point that touches the y-axis. So something to note here, so here is my y-intercept. A y-intercept is always going to have an x value that is equal to 0, and then our y value will be some number that is on the y-axis. In this case, our y-intercept was 0, negative 3. All right, we're going to move to the next slide. I want you to go ahead and preview it and then pause it to work on evaluating it yourself. And then once you unpause it, I will have the solution available for you to check. Okay, it's your turn. Now you have the equation y is equal to negative 2x plus 3. Go ahead and select some points. For me, I'm going to stick with my negative 1, negative 2, 0, 1, and 2. You don't have to pick those points, but if you would like, it's always a good starting point. So please go ahead, pause the video, and when you unpause it, again, the solution will be available to you. Okay, here is our solution. So please go ahead and take some time, maybe pause the video to look through the work if you need to. But notice in this case that this time our line is going downward. And this is just a kind of future note for yourself, but it is going downward mostly because we have a negative that is happening in that equation. Where if I flip back to my other one, where my 5 was positive, So notice that there is no negative sign here. And this line was trending upward when we read it from left to right like a sentence. But again, here, because there is a negative out in front of where our variable is located, we're seeing it trending downward when we read it from left to right. As before, notice that when I used 0, I was able to uncover the y-intercept at the point 0, 3. All right, so one more slide and we're ready to wrap up this video. So for the final portion of this video, I just wanted to show you some variations of the equations that you might encounter so far. So in the first one, we have y is equal to negative 4x. And what I want you to note in this case is that this is nothing to worry about, but you might be looking at it kind of saying, well, where is the plus or the minus number after? And in this case, what we want to note here is that it's actually plus 0. So because they were just adding 0 to it, or in other words, nothing, they decided that there was no need to add that value in. If you wish to write it in just to see it, and if that helps you, I would highly encourage you to do that. The next one that we're going to take a look at is going to be y is equal to, in this case, 2/3 x plus 1. So this time you might be looking at it going, ooh, a fraction. Maybe you don't like fractions, maybe they're just not fun, maybe you just don't like this one because it has a 3 in the denominator. So when you are starting to build a table of values, if you are about to graph this, your best bet is to pick numbers that will help you get rid of that denominator. So this actually gives you some important information to help you out. So say, for example, I'm looking at creating a table, and I want to be careful about what x values I select. Well, I'm going to pick multiples of 3 here. So negative 3 might be good if I wanted to work with a negative number. 0 is always good, and I will explain that shortly. And, I could pick something like 6 or 9. So let me run through a couple of examples with you. So say, for example, we pick negative 3 to go in for x. Well, then we would have y is equal to 2/3 times negative 3 plus 1. What might help you here is to write that negative 3 so that it's a fraction, or that it looks like a fraction. Because hopefully what you're kind of noticing is, in this case, that the 3's will cross-reduce out. So that 3 will cross-reduce, that 3 will cross-reduce, so that leaves you with a 1 and a negative 1 here. My result then would be y is equal to negative 2 plus 1, or y is equal to negative 1. 0 is always a nice one to work with. So if, for example, we did this one, I'm going to go ahead and write it over here, y is equal to 2/3 times 0 plus 1. Well, even if you write it as 0 over 1, 2/3 times 0, that basically just makes this whole thing go away or become a 0. So now we have y is equal to 0 plus 1, or y is just equal to 1. Lastly, maybe let's do the one with 9 in it. If I do y is equal to 2/3 times 9, and I'm going to write that 9 over 1, plus 1, again, I can cross-reduce. The 3 will become a 1, the 9 will become a 3, because I was able to divide both of those numbers by a 3. My result ends up becoming y is equal to 2 times 3 is 6 plus 1, or y is equal to 7. So as you can see, by strategically picking x values, I'm able to kind of sidestep working with too many fractions. I hope that was helpful. Go ahead and proceed on to the next video.